Hello, ladies and gentlemen, and welcome back. We're looking at the very last question on the 2007 Galois paper. So it's question number 4 here. And Jill has a container of small cylindrical rods in 6 different colors. Each color of rod has a different length as summarized in this chart. So green is 3 centimeters, pink is 4, yellow is 5, black is 7. Kind of odd that we skipped 6, but that's okay. Violet is 8, and red is 9. These rods can be attached together to form a pole. And then we have an example. There are 2 ways to choose a set of yellow and green rods that will form a pole 29 centimeters in length. 8 green rods, so that would be 8 times 3, 24 centimeters. And 1 yellow rod, so that would be 24 plus 5, that's 29 centimeters. And the other option is 3 green rods, so that's 9 centimeters in total, and 4 yellow rods, there's the other 20. Okay. Alright, so we're just sort of putting together different colors of rods, I guess. And we got 3 questions here. Question A, how many different sets of yellow and green rods can be chosen that will form a pole 62 centimeters long? Explain how you obtained your answer. Alright. So what I'm going to do is I am going to try and get 62 centimeters somehow. What's the best thing for us to do? I think maybe try to use as many greens as possible for our first attempt here. Okay, so 62 divided by the 3 centimeters that comes with a green. Well, 62 is almost 63, so that'd be 21. So can I do 21 green rods? Well, no, because that would be 63. But let's try 20 greens. Then that would give me 60 centimeters. And then I'd have 2 centimeters left over. Well, yellows are 5, so that's not going to work out. How about we try 1 less green? So let's try 19 greens. That would give me 57 centimeters. And what's left over? 5 centimeters. That's perfect. So 19 green and 1 yellow works. Now, I could keep decreasing the number of greens, and then eventually I'll find in a little while we get some more yellows. Or we could put a little bit of thought into it, put a little bit of math into it. 5 greens is the same as the length of 3 yellows. So if I want to lose greens, I'll have to gain yellows, because we're keeping 62 centimeters constant. So to lose 5 greens, gain 3 yellows. That's the easiest way to do this. So 14 greens. And so we lose 5 greens, we add 3 yellows. So 14 greens and 4 yellows works. Okay, we lose 5 more greens and gain 3 more yellows. And if you want to, at any point, check these out. 9 times 3 is 27. 7 times 5, 35. 27 plus 35 is, in fact, 62. So let's lose 5 more greens and gain 10 more yellows. And that's all that we can do, because you can't lose 5 more greens. Okay? And you might say, okay, you figured this relationship out. How did I figure this out? Well, because suppose K centimeters was equal to A greens, but also equal to B yellows. Then K would have to be A times 3 centimeters, but it'd also have to be B times 5 centimeters. So 3 divides K, 5 divides K. The smallest number that does this is K is 15. The smallest positive number that does this is K is 15, and that tells me A is 5 and B is 3, and that's exactly what we've got. 5 greens, 3 yellows. Okay? There are other expressions. You can write 30 centimeters in both just greens and just yellows, but we go with the smallest expression so that we have the we don't miss anything. Okay. So there's 4 expressions, and we actually do have them all written out. Okie dokie. So what's up with question B? So B, among the green, yellow, black, and red rods, find with justification 2 colors for which it is impossible to make a pole 62 centimeters in length. Well, we know we can do it with green and yellow. And if we wanted to, we could just run down the list. You know, can we do it with green and yellow? Well, yes, we can. Can we do it with green and black? Can we do it with green and red? Can we do it with yellow and black? Can we do it with yellow and red? Can we do it with black and red? Okay? And we can certainly go through this list and mess about and try and find the right thing. But let's for a moment take a look at what colors, what these colors actually bring to the table in terms of length. So green is 3 centimeters. We've got black. Oops, sorry, yellow was first, wasn't it? Yellow is 5 centimeters. And black is 7 centimeters. And red was all the way at the end. Red is 9 centimeters. So yeah, we could just take pairs of these and see what, if anything, we can do. But if we stop and take a look for a moment, green and red have this nice property, and they're both multiples of 3. So let's for a second suppose that A greens and B reds made 62 centimeters. Okay? Then we'd have A times 3 plus B times 9 is 62. But over here on the left-hand side, that's divisible by 3. But the right-hand side isn't divisible by 3. 62 is not divisible by 3. So since 3 doesn't divide 62, but 3 would have to divide the length of any amount of greens plus any amount of reds, we've got a problem. So this is what's known as proof by contradiction. We assumed that we could do something. We showed right here that that was ridiculous. So our assumption that we could do something must have been wrong. So we can't use greens and reds. Okay? And if we take a look, we can actually do every other possible combination. It's just greens and reds. And it's just because they're multiples of 3. Okay? So there we go. We've got B part done. And now we'll flip the page and we'll get ready for C part. What have we got going on here with C part? If at least 81 rods of each of the colors green, pink, violet, and red, so what are these? 3, 4, 8, and 9, must be used, how many different sets of rods of these 4 colors can be chosen that will form a pole 2007 centimeters in length? Okay, now it seems like a lot, but they're already asking us to use 81 rods of each color. So how much do those 81 rods actually account for? What's that length? So we got our greens, our pinks, violets, and reds. So 3 plus 9 is 12, 4 plus 8 is 12, so this is 81 times 24 centimeters. Let's see, there's a factor of 3 in there, so that's 243 times 8 centimeters. I'll just multiply it out. So 4, 3, 2, 0, 2, 6, 1, 4, 4, 9. So it's 1944 centimeters is already accounted for. We only need to concern ourselves with the remaining. So what we have to do is make up the remaining distance, the remaining length. And that's going to be 7 minus 4 is 3. And then, 63. Huh. I would have thought it might be 62 with all that they were talking about with the previous two questions. 81, 24. Yeah, it should be a multiple of 3 because we got a multiple of 3 here, and we definitely have a multiple of 3 here. So, yeah, 63 centimeters. Okay. So now our question becomes, how can we use 3, 4, 8, and 9 to make 63 centimeters? That's our new challenge. Alright, now there's a lot of possibilities, a lot of possible combinations, but just like with the last question, take a note, 63 is a multiple of 3, so we can just use some greens and reds, but we could also do other things. But rather importantly, 63 is a multiple of 3, so this 4 here, that's not a multiple of 3. 8's not a multiple of 3. 4 plus 8 is. So I can make a few observations here. So 63 is a multiple of 3. So there will either be... How do I want to phrase this? I want to say you can pair up the 4s and 8s. So the greens and reds don't affect this. But for any pink, those are the 4 centimeter ones, we need either two other pinks for a total of 12 centimeters, or one other violet, again for a total of 12 centimeters. And if you have a violet, remember those are 8 centimeters, what do we need? We need either 2 other violets, and that's getting pretty big. So that'd be up to 24 centimeters that we've accounted for. Or one other pink. Again, giving us 12 centimeters. Okay? That's the challenge. We can, greens, any amount, reds, any amount. But as soon as I have one pink, that either forces 2 more pinks or a violet. And that kind of gets things going and narrows down our possibilities. So, to list these possibilities, I'm going to start the same way I did in A. But instead of trying to get, say, the most greens, I'm actually going to try and get the most reds. Okay? Why is that? Well, the reds account for the most in terms of length. They're 9 centimeters long. So it's going to be fairly quick to figure out, well, how many reds at most could I be using, and go from there. Okay. You could do this by figuring out the most greens you can use and going from there, and that's fine too. As long as you are methodical, you're not going to miss anything. And with a question like this, yeah, our reasoning is important. Knowing that adding 1 pink gives you 2 more pinks, that's good. But what's more important is making sure that our list is complete. And so you have to get into the habit of writing these things in a methodical way. Now, we've got 63 centimeters to make. Reds give us 9 centimeters, so that's a total of 7 reds. So 7 reds on their own, that's fine. And we might even try and make a chart of reds, violets, pinks, and greens. So 7, 0, 0, 0, that's fine. What if I had 6 reds? Well, 6 reds, that's 54. We've got 9 left to make up. Can I get 9 by putting in a violet? No, because, yeah, a violet's 8, but we would need at least a pink left around, and that's a total of 12. And if you feel the need to, you can write all this up. When you actually see the papers, there's not that much room. I mean, it's a good solid sheet, but you're not writing every single thought that pops in your head when you're writing these things up. What you want to do is show your basic reasoning, our multiple of 3 stuff. You want to start writing out this chart. Now, if there's any particular trick you are using, yeah, you want to write that up. But if we're just going to start listing things out, it's fine to say R6, violets are 0, and pinks are 0, and greens are going to have to be 3. Okay? When we get down to R is 5, well, then we might have some pinks around. And it might be a good idea to explain how you went through those possibilities. It's entirely up to you. Practice these things. Well, obviously that's what you're here doing. But as we practice these things, we get a sense of our own style of writing things up, how much we're comfortable writing, how much we're not comfortable writing. And as we write more contests and get more feedback in terms of marking, we start to see what is a waste of time in terms of writing too much up, and what in our writing needs more clarification. Okay? But here we're going to have 3 greens. Okay? Now what happens when we go down to 5 reds? I'll say left over here. So what's left over when we do 5 reds? Well, that's 45. So we're going to have 18 centimeters left over currently. Over here was 9 centimeters, and that's why we had 3 greens. If I have 18 centimeters, can I put in 3 violets? No. Because that would be 24. Could I put in 1 violet? Absolutely. And you'll notice I'm going methodically. I'm considering my violets. What's the most number of violets I can have? And then I start doing pinks and greens. If I have that 1 violet, I have to have this 1 pink. Now that's a total of 12. So we're left with 6 centimeters, 2 greens. But who's to say I had a violet? Maybe I didn't have a violet. I could have 3 pinks. Okay, I can't have 6 pinks. And since I'm not pairing a pink up with any violets, I'm going to have a multiple of 3 in terms of pinks. So that'll still leave me with 6 centimeters. I'll have 2 greens. 5. What if I have no violets or pinks? Well, now we're just purely in the greens. That's going to be 6 greens. Okay? So we see we sort of move left to right in this way, and we're not going to miss anything. Okay? We're going to flip over to the next side. We're going to consider 4 reds. And I'll still keep track of what's left over. So 4 reds. That's 4 times 9, 36. So that's going to be 27 left over. So now we can have 3 violets, and that'll leave me with 3 centimeters. Not enough for any pinks, but we can certainly have a green. Okay. What if instead of 3 violets, I wanted maybe 2 violets? Well, both of those are going to have to be paired up with pinks. That's still 24, so that still leaves me with 3 centimeters. Going to have 1 green. What if I only wanted 1 violet? Well, he has to be paired up with a pink, doesn't he? Okay. But now I'm left with 15 centimeters. So I have a choice. I can have some more pinks. I can have 3 more pinks and be left with 3 centimeters and 1 green. Or I could choose to have no more extra pinks, and then all 15 centimeters go into the greens. Okay. So there's all 4 possibilities with R's 4. How about 3? Well, you'll have 36 centimeters. And what could we do? Well, we can have 24 violets. And in fact, we could have 4 violets and then 1 pink to balance out our extra, our sort of 4th wheel violet here. And that's going to leave things quite nicely there. We could have 3 violets, and then we'll have 12 centimeters left over, so we could either have... Oh, my mistake. I completely forgot to consider what if I had no violets at all? Okay, well then we'd still have 27, so we could have something like 6 pinks. Okay, 6 pinks would be 24, and we'd still have 1 left over for our greens. Or maybe we only have 3 pinks. Remember, the pinks, when there are no violets, have to come in groups of 3. Okay, that might be something to write off to the side. Pinks, when there are no violets, have to come in groups of 3. Violets, when there are no pinks, have to come in groups of 3. But that would then turn into some more over here. Yeah, 5 more over here. Or maybe we have no violets or pinks at all. That's always the way we should end it. And then that would be 9 greens. Okay. So it's becoming quite a list. I'm just going to double check. Was I asked to write all these out? How many different sets of rods of these 4 colors can be chosen? So I actually don't have to write them all out. And I'm wondering, is there a faster way to calculate all of this? I'm not noticing exactly a pattern as I fill this in. There's one with V being 3. There's 1 with V being 2. There's 2 with V being 1 and 3 with V being 0. Is there a similar pattern over here? Not really. Not really. So I think I'm just going to keep listing them out until I notice something to do. Okay? And if you find a faster way, I would love to know about it. So if I have 3 reds, what can I do? Well, 3 reds, that's going to leave me with 36. We already talked about this, didn't we? We could have 4 violets, so that's 32, and 1 pink. And that's no greens. That's the best we can do with 4. What if we had 3 violets? Well, so that'd be 24. That would leave us with 12, so we could have 3 pinks, and again, no greens. Or we could have no pinks, and now we'd have 4 greens. Well, what if we had 2 violets? Okay, well, we'd have to have at least 2 pinks, and that gives us a total of 24. But that would still leave us with 12 here. So we could put 3 of those into the pinks. That would get rid of everything. We'd have no greens. Or maybe we only have the 2 pinks. Notice that the pink numbers go down by 3 every time. Okay, so that would be 4 greens there. What if I only had 1 violet? Well, I'd have to have another pink standing by. But that would leave us with 24. I could have 6 more pinks there. So that'd be 7, 4, 1. I'm starting to just fill in this chart almost automatically. And then whatever is left, I don't care exactly the number of greens. I know I'm always going to be able to fill it up. Okay, so I don't need to keep working out these numbers in my head or anything like that. Okay, now what if I had 0 violets? Okay, I could have 3 reds, 0 violets. That's going to leave me with 36. Well, I could make 9 of them pinks. Have 0 greens. Or I could, and this starts to decrease by 1. And there we go. They all fill in. So it certainly seems to be working out that I'm filling this out a little faster. What if I had 2 reds? I still have to go through 2 reds, 1 red, and no reds. So let's see. Let's stay on the hunt for patterns. If I had 2 reds, that accounts for 18 of the total 63 length that I want. Okay? So what's left over? 45. Okay, how many violets could I reasonably fit in here? Well, I can't do 2 sets of 3 because we're not up to 48 yet. So we can't do 6 violets. Maybe we could do 5 violets, and then that would be 2 pinks, maybe? So that'd be 40 plus 8. Well, no, that's still a little too much. Okay. No problem. So we'll start with 4 violets. Okay. 4 violets, that would leave 32. So that's a difference of 13. Okay. So I would need at least 1 pink. That would get me down to 9. And then the remaining 3 would have to be green. Okay, what if I had 3 violets? Well, then at most I could have... So trading 1 violet boosts the pinks up by 2. Okay, so I could have 3 pinks if I think I'm making sense here. So 3 violets, that would be 24. That would leave me 21. 21, but I could definitely have 3 pinks there. Oh yeah, no, so that did go up by 2. Okay. Or I could have none of those, because I can go down by 3 here, and some number of greens. And now that we're out of pinks to go down, we decrease the number of violets. So 2, 2, we're going to have this number go up by 2, because we lost the number of violets. So we'll go up to 5, and then down to 2. Alright, we're starting to make a bit more progress. And rather than flip the page, I'm just going to continue on. So red, violet, pink, green. So it's starting to get a little more algorithmic. Now we decrease the number of violets. Increase the largest number of pinks that we just saw by 2, so we're up to 7. And some number of greens, and this goes down by 3 each time. Yeah, there's definitely a pattern going on here. How about 0? Well, then that 7 goes up to a 9, 6, 3, 0. Alright, so before I keep going, I have 4, I have 3, I have 2, I have 2, I have 1. I have 4, I have 3, I have 2, I have 2, I have 1. Okay, we'll try a bit more. Here I only have 3, 2, 1, 1. I think there's something going on. I'm just not sure what. And if I'm not sure what, I don't know how to start trying to express it. So I think we're just going to keep going now with the R is 1. Violets, pinks, greens. So if R is 1, that leaves 54, so I can finally have 6 violets. Okay, 6 violets. I'm not going to be able to fit 3 more pinks in there, so he would have to be 0 and green would be some number. Decrease the number of violets. I can increase the number of pinks by 2. Some number of greens. And pinks can't go down anymore, so 4. Increase by 2. But now I can decrease. And now 3, and I should get 6, 3, 0. 2, we go 8, 5, 2. Now the violets are 1. So we would go up to 10 pinks. 7, 4, 1. And then 0, we go up to 12, 9, 6, 3, 0. Okay. So I'm starting to fill this out without having to do a whole lot of other stuff. And we only have one more to go. But I'm getting the sense that there probably is a faster way to do this. There's probably a pattern I'm just not seeing. Maybe I would have seen it if I'd started with the greens instead. I don't think so, but you know, there's always possibilities. So if there are no reds, we just have 63. Well, I can't have 8 violets, but I can have 7. And that means I need 1 pink, and then it'll be 1 green. Decrease the number of violets by 1, increase the greatest possible number of pinks by 2. And then that can go down to 0. 5, we go up to 5, 2, 4, we go up from 5 to 7, 4, 1. 3, we go up to 9, 6, 3, 0. 2 for the violets. It's all about violets and pinks, really. 2 for the violets, so the pinks goes from 9 up to 11 as our maximum. 11 goes down to 8, 5, 2. 1 violet means 13 pinks at most. That's 10, 7, 4, 1. And finally, 0 violets goes up to 15, 12, 9, 6, 3, 0. Okay. So let's count things up. We've got 5, 4, 4, 4. So that's 17 right there. 20, 22, 24, 25. Okay, so there's 25 with R is 0. What about when R is 1? It's 5, 4, 3, 3, 2, 1, 1. So that's 5, 4, 3. So that's 12 plus another 3, 15. 2, 17. And then another 2 is 19 when R is 1. Okay. And then we get 4, 3, 2, 2, 1. So that's 12. Seems kind of small, but okay. 4 when R is 3. 3, 2, 2, 1. So that's another 12 when R is 3. And now when R is 4, we get 3, 2, 1, 1. So that's 7. When R is 5, we have just 3 of them. When R is 6, we have 1. And when R is 7, we have 1. So 1, 1, 3, that's a total of 5. I'm not noticing a pattern 1, 1, 3, 7, 12. Nothing there. So 5 plus 7 is 12. Plus another 12 is 24. Plus another 12 down here is 36. Plus 19 is 46. Plus 9 is 55. Plus 27 is 75 plus 5, a total of 80. And I genuinely can't think of a better way to get that. And that seems kind of long for question 4 on a Galois. It seems like a sort of a pointless listing question. So I get the sense that maybe there was another mathematical property I should exploit. So just give me a second. I'm gonna see maybe if I can see anything, but also I want to double check my arithmetic and make sure I didn't miss any of the possibilities, because I was going kind of fast at the end. Got into a rhythm because there was a real pattern. Alright, so let's count here. So 6. Oh, am I still in red? Yeah, I was. Okay. Or not red, black. 6, 5, 4, 4, 3, 2, 2, 1. So that's 3, A 5, you can skip ahead if you know I got the right answer, by the way, because it's probably just going to be boring accounting, but we still do want to double check that my arithmetic was correct. I think methodically I'm fine, but, I'll think about it as I go back and look at these. 3, 5, 8, 12, and that, oh, that's not 25 at all, that's 27. Right, 6, 5, 4, so that's 15. Plus another 5 is 20, plus the 4 is 24, plus 7, 27. So I'm off by at least 2. Did I count the others wrong? 5, 4, 3, 3, 2, 1, 1, 4, 10, 19. Okay, that number checks out. 4, 3, at least at this point I started labeling them in blue. 4, 3, 2, 2, 1. Yeah, that's 10 plus this 2 makes 12. The other one was 4, 3, 2, 2, 1. So it's also 12. So that number checks out. These ones got small enough that I started being able to just count them on sight. Yeah, so adding wise, I guess I goofed a little bit with that 25. And the answer is not 80. I guess it's 82. But as I was saying, this is kind of long for a listing question. I mean, you'd expect some of the weird stuff on maybe a Hypatia, but not this. So 82 possibilities. I'm confident in my list method. Okay, I'm very confident in the way that I was able, we said we're going to start with the reds. I started with that because it was the biggest. Then we moved on to the violets, the next biggest. They just took up more, and so their numbers would be smaller. There's no reason you couldn't start with the smallest. We just have a lot of empty sort of green cases, that sort of thing. But I'm confident that I didn't miss anything, and the pattern at least was recognizable, that I was able to fill the charts in very fast. So far, the only goof I've noticed is that I miscounted by 2. But double-checked and more confident that 82 is the answer. I'm going to go check their solutions because I'm very curious to see if there was a fast trick way to do this. And if you did it a different way by doing something other than listing, I would love to hear about it in the comments. Just leave one down below and I'll take a look. But 82 is our answer, and that's going to finish off the 2007 Galois paper. If you're looking for more written contests, I will have the 2007 Hypatia up. If you're looking for more grade 10 level content, I do have the 2007 Kaylee. And for more Galois, the next one I will be doing is the 2008 sometime in the future, so stay tuned for that. Thank you for watching. I'll see you next time.